And if we write this is Lyx, this equals to, if we take this is a second order differential equation, so we can write here this plus a1x y prime x plus say a2x and yx. Okay, so this is homogeneous. This means this equals to 0. This and here we consider this is non-homogeneous. So this equals to non-zero component. Say if we consider something dx, where x is belonging to some interval I which belongs to R. Okay, so here with what is d here? D is any continuous function on that interval I. Okay, so here we can write this is d is continuous function is continuous on that domain I. Okay, so if we suppose the homogeneous, if we try to write this linear differential equation, if dx equals to 0, this means this linear differential equation is your homogeneous. If dx be non-zero, or if we take any continuous function, which is this continuous function, or we can write this non-zero terms. So this means this differential equation is non-homogeneous. Okay, so if that dx equals to 0, so we can write this is homogeneous differential equation, and the solution of that differential equation we write simply y of h. Yh means this is a homogeneous solution of this differential equation. Okay, so if this is not equals to 0, so this means this is the general solution of homogeneous differential equation. Okay, and if this dx is not equals to 0, so we can write we are interested to find what is the particular integral, and in graduation you have already studied how to find the particular integral of any differential equation. Okay, so here what is the general solution of this differential equation is basically you can write this is the homogeneous part plus this is the particular part. So this is the general solution of your given differential equation. Okay, so here in next page we can write this form in detail.
Sir,
okay,
oh, sir, D where D is क्या लिखा है sir?
But these continuous basically okay. So
okay, sir.
Where these continuous function on that interval basically. Okay. Okay, so this part we have already studied in the previous class. So now the next page we can write a theorem which is based on that this part y equals to yx plus yp. Okay, so in next page let us start our theorem, which is a small theorem. The proof of that theorem is basically in 2 lines. Okay, so here this is basically a remark. So if we write this as a theorem, and this theorem says that if we suppose this, if you write yp is any particular solution of your differential equation, and if we write this differential equation is if we write say this is linear operator and this equals to, in previous page we can write this is y double prime x plus a1x y prime x plus a2x yx. Let's say this is equals to dx, and here this x belongs to an interval I, and say this is this is equation of double stub. So if yp is any particular solution of this given linear differential equation, so if we write of this equation which is existing on that particular interval I, okay, so this existing on interval I, and if we write the homogeneous part, say YH is that equation is we can write shortly as this thing something 0, means this equals to 0, dx equals to 0 on that given interval I. Okay, so then this theorem says that if this condition holds, then our y be the solution of this given differential equation. This is the L of this yx, then y be the solution, and that solution is basically the particular integral and homogeneous, or yh plus yp. Okay, so this is basically a general solution. This is a general solution of your given differential equation, and which is marked as equation double star. Okay, on this given interval. Okay, so you know that if we take any second order linear differential equation and homogeneous differential equation, this means a naught x y double prime x plus y a1 x plus y y1 y prime x plus a2 x yx, that equals to 0. So here if we call this differential equation is homogeneous if dx equals to 0, and this a naught x is not equals to 0. Okay, so if we try to reduce this in normal form, so we divide by a naught x here, and if this is equals to 0, so a naught 0 upon a naught x, that equals to 0. Okay, so if a naught x is not equals to 0, then this differential equation is homogeneous. If a naught x equals to 0, so that particular value of x when this a naught x equals to 0, that the singular point. Okay, so we will discuss at that point in detail after that completion of that portion. Okay, so what is the proof? If we try to prove this part, this is very simple. Basically, if we consider that is the solution, and if this part is the solution, and we are able to prove that this y satisfies this equation, this means this is the solution of given differential equation. Okay, so idea is simple. If we take this yp plus yh be the solution of this equation double star, and we are able to find this condition is satisfied, then this yp plus yh be the solution of this given differential equation yp plus yh. Okay, so here if we consider this yp plus yh, basically the homogeneous solution and particular solution, this is a solution of the equation, given equation, say to start, and since what is your Ly, so Ly is equals to, so L of y, this equals to, what is the y? If we take this yp and plus yn be the solution, so we simply write here yp plus yh. Okay, and this is the linear operator, so this yp and plus this is yh. Okay, and here this L of yh means this is the solution of homogeneous differential equation. Okay, so what is the homogeneous differential equation? This means if we write here what is the homogeneous differential equation, so this is a naught x y prime plus a1 x y prime and a2 x yx, that equals to 0. This is your homogeneous differential equation, and the solution of this we can write this portion as yh equals to 0, because yh will be the homogeneous solution of that part. Okay, so this means here yh equals to 0, and what is value of yp here? If we write this Ly, so this equals to basically L of y, that equals to dx. Okay, so this implies write here this dx plus this is 0 because L of y is equals to 0. So this equals to dx, and where x belongs to I. Okay, or we can say that okay, so we can write this y is solution of this double star. This is n parameter family of function, because this YH is that part, because in YH there are C1, C2 up to Cn, there are n constant. Okay, so this Y is basically the general solution of equation double star. Okay, so here this means this theorem says that if YH be the homogeneous solution of this differential equation, so and YP be the particular solution of the given differential equation, so the general solution of this given double star is marked by this YP particular integral plus homogeneous equation. And here we see that this, if we put here, and this satisfies our this condition, so this means this is the solution of given differential equation. Okay, if you try to see in any problem, and this problem, if we write this thing double prime minus 2y equals to 0, where x belongs to r plus. Okay, so in this integral, in this differential equation, if we integrate and try to solve what is the homogeneous, the solution of this homogeneous differential equation, so here there are two solutions due to this second order differential equation. First one is x square, and y2x is 1 by x. These are two solutions of this homogeneous differential equation. Okay, so here we can write the solution of, then the solution of that is c1 plus x into x square, c2 of 1 by x. Or in other method, you can try to solve what is the roots of this solution, and you can check the roots of that differential equation. So if these two are this y1x and y2x are basically linearly independent solution of this, so you can write the homogeneous solution of this is some constant x square plus c2 of 1 by x. Okay, so if this differential equation, if we consider like this, y double prime minus 2y, it is equals to 0. So if we write here some non-zero part, that is dx, and if we write that dx be the continuous function on that domain, so if we reduce this is simply, if we write this is 2x minus 1. Okay, so this is your dx, which is the continuous function.
एग्जाम्पल समझ में नहीं आया, क्या आप बताना चाह रहे हैं इसमें?
Basically this is a second order linear differential equation that equals to 0. Okay, and here y1 and y2 be the solution of this given differential equation. Okay, this means if we put y1 here, y1 equals to x square. So if we differentiate this one time, so this becomes 2x, and if we differentiate second order differential, that is equals to simply 2. This we write here 2 of x square minus 2 of that y equals to x square. This means 2x square minus 2x square, that equals to 0. This means y equals to x square satisfies this differential equation. This means y1x be the solution of that differential equation. That part we had already discussed in previous classes. This means this satisfies this second order differential equation. So this be the solution of y equals to x square be the one solution of this given differential equation. Similarly, if we take y2 equals to 1 by x, this is the another solution of that differential equation, and these two are linearly independent if you try to find the Roschian of that too. Okay, so this be the linearly independent, and if these two are independent solution of given differential equation that is homogeneous differential equation, then the solution of differential equation is, we can write this C1 of first one plus C2 of second one, and this the linear combination of these two be the general solution of this homogeneous second order homogeneous differential equation. This part is we have already studied, so that's why we can write directly this is the solution of that part. Okay, here we
you have written in the second line that L of y equals to L of yp plus yh. Sir, then after you have written that d of x is plus 0. Sir, ये 0 कहाँ से आ गया?
0, this 0, this L of yh equal to 0 because आप ये जानते हो कि yh जो है वो हमारा क्या है, yh जो है वो हमारा solution है, this is the solution of homogeneous equation. Okay, so this is given here. This is the general solution of homogeneous equation of this thing. Okay, तो general solution है homogeneous. तो homogeneous equation कब होगी? When dx equals to 0. When dx equals to 0, that is we call this y of h, because y is the solution of that, y is the solution of that differential equation. This is homogeneous. So we have yh. Yh means this is the general solution of homogeneous equation. So this means L of yh equals to 0. So that will be that equals to 0. Okay.
Okay, sir.
Okay. So here यहाँ पे सिर्फ ये मेंशन ये करना चाहते हैं कि ये आपका जो जिसको फाइंड किया है, तो उस पर हम टाइम ज्यादा ना देते हुए हमने सिंपली बता दिया कि y1 इसका एक सोल्यूशन है इस सेकंड ऑर्डर डिफरेंशियल इक्वेशन का, जो कि होमोजीनियस है ड्यू टू dx पार्ट इज 0. तो y1x इसका सोल्यूशन है, y2x भी इसका सोल्यूशन है. यदि आप इसकी रॉस्कियन निकालो तो ये आप इंडिपेंडेंट हैं, ये दोनों सॉल्यूशंस हमारे लीनियरली इंडिपेंडेंट हैं. तो जनरल सॉल्यूशन ऑफ दिस टाइप ऑफ डिफरेंशियल इक्वेशन जानते हो आप कि दिस इज C1 ऑफ फर्स्ट वन प्लस C2 ऑफ ये होती है इसकी. ओके, तो ये आपके जनरल सॉल्यूशन हो गए इस सेकंड ऑर्डर होमोजेनियस डिफरेंशियल इक्वेशन के. हमने क्या किया, यहाँ पे सिर्फ ये 0 को हम रिप्लेस कर रहे हैं एनी फंक्शन ऑफ dx, एंड दैट dx बी द लीनियर फंक्शन, एनी कंटीन्यूअस फंक्शन ऑन दैट डोमेन. तो हमने यहाँ पे एक कंटीन्यूअस फंक्शन, आप चाहे तो लीनियर ले लें, चाहे क्वाड्रेटिक ले लें, कुछ भी ले लें, हम एक सिंपल फंक्शन ले लें जो कि कंटीन्यूअस फंक्शन होना चाहिए इस डोमेन आई में. यहाँ आई डोमेन आपका क्या है, विच इज r प्लस. Okay, so if we replace this 0 by this thing, what is the solution of that this new differential equation? तो इस नए differential equation को अगर हम ये फॉर्म का तो solution हमें मालूम है yh, बट अगर हम ये फॉर्म लिखें जहाँ dx is not equals to 0, then solution of that differential equation क्या होंगे? तो बेसिकली जो solution होंगे वो हमारा जो होगा उसके लिए आपको मालूम है कि आप क्या करते हो, यहाँ पे पर्टिकुलर इंटीग्रल निकालते हो इन ग्रेजुएशन लेवल में. ग्रेजुएशन लेवल में आपके पास वेरियस मेथड्स होते हैं. इफ डी स्क्वायर माइनस ए स्क्वायर है, एक्सपोनेंशियल फंक्शन हो तो हम क्या लिखते हैं, हमारे साइन कोसाइन फंक्शंस हैं तो हम क्या करते हैं. ओके, सिंपल हमारे एक्सपोनेंट कांस्टेंट है तो क्या करते हैं, हमारे पॉलिनोमियल है तो क्या करते हैं, प्रोडक्ट ऑफ एन एक्सपोनेंशियल इनटू फंक्शन ऑफ एक्स है तो क्या करते हैं. सारी चीजें आपने ग्रेजुएशन लेवल में ऑलरेडी पढ़ रखी हैं. तो इफ वी अप्लाई दिस पर्टिकुलर इंटीग्रल, अगर आप उस किसी भी मेथड से, आप ये देखो सिंपल फंक्शन ऑफ एक्स है, उस मेथड से अगर आप इसके पर्टिकुलर इंटीग्रल निकालो तो यहाँ आपके पर्टिकुलर इंटीग्रल, इस पार्ट का पर्टिकुलर इंटीग्रल होगा दैट इज 1/2 माइनस एक्स. ओके, सो दिस इज योर पर्टिकुलर इंटीग्रल. ओके, हम डायरेक्ट लिख रहे हैं कि ये इसके होमोजेनियस सोल्यूशन है और ये इसके पर्टिकुलर इंटीग्रल. क्लियर? तो जनरल सॉल्यूशन क्या होंगे, जनरल सॉल्यूशन क्या होंगे, yh plus yp be the general solution of this given differential equation, because this yh is the homogeneous solution of this homogeneous differential equation. तो हम करते क्या है, आप ग्रेजुएशन में आपने पढ़ा होगा कि अगर हमारा नॉन होमोजेनियस डिफरेंशियल इक्वेशन है where dx equals not equals to 0, तो इसको आप इक्वल्स टू 0 करके आप वहां से आप इसके होमोजेनियस सॉल्यूशंस निकाल लेते हैं, एंड देन पर्टिकुलर इंटीग्रल dx के लिए आप क्या करते हैं, पर्टिकुलर इंटीग्रल निकालते हो और YH प्लस YB
वन कहाँ से आया?
क्या क्या
2x-1
2x माइनस 1 हमने कंसीडर किया है, दिस इज अनदर एग्जांपल। ये हमने सिर्फ आपको ये बताया कि होमोजीनियस डिफरेंशियल इक्वेशन यदि है, दिस इज होमोजीनियस डिफरेंशियल इक्वेशन, तो इसका सोल्यूशन ये होगा YH इक्वल्स टू दिस थिंग। यदि हम ये कंसीडर करें अनदर डिफरेंशियल इक्वेशन वेयर dx मेरा जीरो ना हो, कुछ भी आर्बिट्ररी हम फंक्शन एक बना लें, दिस पार्ट आपने क्या किया है, एस्यूम किया है, दिस इज एस्यूम, ओके, या फिर आप कुछ भी इसको मान लें, ठीक है। dx आप 2x माइनस 1 ले सकते हो, या कोई साइन का फंक्शन ले लो, या फिर कुछ भी आप इसको, इस पार्ट को आप कुछ भी आप
सर इस टाइप में x इक्वल टू e टू द पावर z वाला करके बनाते हैं ना।
हाँ। तो आपने ग्रेजुएशन पढ़ा है, अगर आपने नहीं पढ़ा है
इसी तरह से इसका yp निकाल लेंगे।
एक बार आप, हम तो ये मान के चल रहे हैं कि आप ग्रेजुएशन में आगे सारी चीजें पढ़ के आए हो, तो फिर हम तो सिर्फ आप एग्जांपल दे रहे हैं, क्या हम ये मान के चल रहे हैं कि ये सारी चीजें आपको आती हैं, बिकॉज दिस इज द पार्ट ऑफ इन यूजी सिलेबस, ओके। अगर नहीं आती है, नहीं आती है तो एक बार इसको अपनी बुक्स देख लें, फिर भी कंफ्यूजन होता है तो एक दिन एक्स्ट्रा क्लासेस हम रख लेंगे, वो आपको हम बता देंगे सारे मेथड्स, ओके। यहाँ पे बेसिकली हम ये जानना चाहते हैं कि यदि हमारा होमोजेनियस सोल्यूशन है तो YH सोल्यूशन होगा, और पर्टिकुलर इंटीग्रल आप यूजली आप निकाल लेते हो, ठीक है। तो जनरल सोल्यूशन क्या लिखते हैं, YH प्लस YP हमारा सोल्यूशन होता है। बट पर्टिकुलर इंटीग्रल निकालने में आपके पास वेरियस मेथड्स हैं यूजी क्लासेस में, ओके। यूजी क्लासेस में आपने वेरियस मेथड्स आपने पढ़े होंगे टू फाइंड हाउ टू फाइंड अ पर्टिकुलर इंटीग्रल, और वहां पे आपको क्या है, आपको लगभग 6 टाइप्स के फॉर्मूले आपको याद रखने पड़ते हैं कि ऐसा फंक्शन निकालना हो तो ऐसे निकालेंगे, आपके पास डिफरेंट आपके पास फॉर्मूले हैं, ओके। तो हमारे पास एक जनरल मेथड है which is basically how to find the particular integral of any differential equation, and basically this is your general method, okay. And this method is very effective and also effective with equation with variable coefficients, okay. तो वहां पे भी आपका ये applicable है जहां पे आपके coefficients क्या हो, variable, ठीक। तो and that method is known as method of variation of parameters, okay. And some universities and colleges that part of variation of parameter, and that method is very effective to find how to find this particular integral of non-homogeneous differential equation. So in next page, here in this example, we see only this is the homogeneous part, what is the solution of homogeneous part, and what is the, if this is non-homogeneous, so how to find the particular integral of that, then the general solution of this equals to homogeneous plus particular, okay. So in next page we will discuss what is the method of variation of parameter, and that method is applicable for how to find the particular integral, okay. So basically this variation of parameters this is a general method that give us a particular solution. So the method of variation of parameter is also affected in dealing with equations with variable coefficients. Okay, so if we consider a simple, or we can write second order equation, and if we write this is equals to a naught x, the second order non-homogeneous differential equation, which is already mentioned in previous page. This is a2x yx that equals to dx, where this is not equals to 0 on if x is belonging to that interval R. So this is non-zero because if that is equals to 0, this is a first order non-homogeneous differential equation. That's why this is not equals to 0. Okay, and where these coefficients, basically a0, a1, and a2, are continuous function on that domain. So the function, this a0, a1, and a2, and of course d, this function, which is from that interval to R, and that function is all are continuous. Okay, so here in previous example, the second order differential equation, we had seen that this if y1 and y2 be the solution of that homogeneous differential equation. So if we consider, suppose y1 and y2 be any arbitrary two solution of, and that two solution are linearly independent solutions of homogeneous differential equations. Okay, so what is homogeneous differential equation? This means we can write this y double prime x plus a1x, y prime x, and plus a2x, yx, that equals to 0. So this means this is a homogeneous second order linear differential equation, and the y1 and y2 be the two solutions of this. If you assume that this y1 and y2 be the solution of that differential equation. If we assume that if we let the constants, this C1 and C2, these two constants are basically parameters. Okay, so if we assume that these two constants, that is C1 and C2, this is as parameters, which is depending on x. So here we have to determine what is your particular integral, that is yp. So how you can find what is your yp? So here we take this yp, which is a function of x. This yp is, here we replace this general solution of this homogeneous solution. So here we can write, we are trying to find what is the particular solution of this given equation 1. So here we replace this C1, C2. These are two are not arbitrary constant. This is a say function of x. Okay. So if we consider this is a replaced by this something function of x, y1 x, and this be the say any particular solution of this differential equation. So we will find what is the value of that u1x and what is the value of u2x. Okay. So here if we take this yp be the solution of this differential equation, and that is your particular solution. Okay, so this means here this x is belongs to that I, and this is equation number say 3. Okay, so then what is the value of your y prime? So if we differentiate y prime x, this means if we differentiate this function, so here we find this u1 and say y1 prime plus y1 u1 prime. This is product for this two, and plus if we differentiate this term, this is u2 y2 prime plus this u prime y2. Okay, so this is the differentiation of this term, and this can be written as y prime is equals to, you can take this y1 prime and here y2 prime. So you take this two terms, okay, where this u1 and u2 are only the function of x. Okay, and in this two term where this u1 prime and u2 prime appears. Okay, so here we do not wish to end up the second order functions for u1 and u2. Okay, so that's why we take this y1 u1 prime and y2 u2 prime that equals to 0. So here we only terms as yp prime that is equals to this u1 y1 prime and u2 y2 prime. So in next page we can write this in separate form. So in next page,
सही बात सर लास्ट पार्ट क्लियर नहीं हो रहा है.
okay, here this is yp equals to, you can write this thing. Okay, you can take, this is the function of x, this is function of x. Okay, so you can write this particular integral by equation number 3. If you differentiate this equation number 3, you get this term yp prime x that equals to this thing. Okay, by using product rule of this term and this term. Okay, and if we recombine this first and third term where u1 and u2 terms are there. Okay, and in second and fourth term there are y1 u1 prime and u2 means derivative of this u1 and u2, and you are not interested to find this second order derivative of this u1 and u2. That's why you can write this yp prime is equals to u1 y1 prime plus u2 y2 prime plus this term. Okay, so in next page we can rearrange this term. Okay, so in next page we can write like this. This is your yp prime x, and that equals to y1 prime x with u1 x and plus y2 prime x u2 x. If we rearrange this term, plus there are two more terms, which is y1 x and u1 prime x plus y2 x and u2 prime x. Okay, if we write this form here, this is u1 x and u2 x, and in these two terms are the first derivative of u1 and u2. Okay, so if we take this term is 0 because we do not wish to end up with second order derivative second order equation for this un and u2. So un and u2 that satisfy this y1x un(x) prime x plus y2x, this part, this u2 prime x, that's equals to 0, and say this part is 0. So if this part is 0, so yp prime x that equals to y1x un(x), and this is y2 prime x u2x. Okay, so this is question number 5. So if we take this equals to 0, so yp prime is this thing. Okay, so this is your important equation, basically this 4, because we use this condition. So if we find the value of u1 and u2, we always use this condition 4. Okay, so if we differentiate equation 5, and here we obtain what is yp double prime x. So that's why here you can see that this first derivative of this u1 y1 prime x plus u1, and this second derivative of this plus we can write u2 and prime y2 prime plus this equals to u2 y2 double prime, and say this equation number 6. Simple differentiation, you use here product rule and here also. Okay, and now if we substitute this equation, this 3, 5, 6 in your main equation, in equation first, so we get, okay, so in first equation, so what is your first equation is a naught this double prime plus a1 this and a2 this. Okay, so if we write a naught multiplied by this, your first equation is basically a naught x y double prime plus a1x y prime plus a naught x y. Okay, and that equals to dx. Okay, so this is your main equation. Here you get what is your y double prime. So if you multiplying here a naught by this term plus adding, if you multiply a1 this term plus a naught y, and y is what is y here? So y is basically, you can take u1 y1 u2 y2. This is your y. Okay, so if we putting these values, so in next page we can write this after putting and take common, so you can write this form. So okay, so we cannot write directly, we can explore this term. So first one is, what is your equation is a naught x, and you multiply by y double prime. What is the value of y double prime is u1 prime y1 prime u1 y1 double prime u2 y2 u2 y2 double prime plus what is your a1, what is y p prime, that equals to y1 prime u1 y2 prime u2, what is a naught a2, and y is u1 y1 u2 y2, and that equals to dx. Okay, so here this is basically yp double prime, this is yp prime, and this is simply yp. So after putting these values, we can rearrange this term. If we rearrange this term, we can write a naught x plus, if we take this y1 prime, so this becomes y1 prime. Okay, so a1 this form, this is a2 this term. Okay, and then a1, here we take this first, and here this and this first one, so this becomes plus, we take a2 of x, y1 x, and here in each term there are u1 term, so this becomes u1 of x, plus in second we take this to this, a2 to this, and here this term. So the second term is, we can write in the form a0 x y2 plus a1 x y2 plus a2x y2. Okay, this multiplied by u2, because this u2 is common to all. Okay, and the remaining terms is this one. Okay, and this one first, and this. The remaining term is, if we multiply by here, this becomes u1 prime a naught x y1 prime. First and second term, this is u2 prime a naught x y2 prime. Okay, so this equals to in right hand side, this is dx. Okay, so if we rearrange this term, this equals to 0. Okay, and here you can know that this c1 and c2, this is the remaining part of that equation, because a naught x with a non-zero, if we take common and if we divide by both sides, you get this thing. So here equation 7 is this, and your equation 4, when equation 4, what is assumed that equation 4 is this is y1x u1 prime x and y2x u2 prime x, that equals to 0. This is equation number 4. So if we try to solve these two equations, equation number 4 and 7, so if we solve for this u1 prime and u2 prime from equations 4 and 7, so we can find, so in next class